Welcome back to the Chasing Tone podcast. Today I have a very special guest. This would be Jake Steffes, who happens to do a lot of engineering here around Wampler. Now, you may have heard him on a previous podcast. He's back again today to answer some nerdy questions. So, my favorite kind. So let's jump right in. All right, everybody. So with me today is Jake Steffes. Jake is, in case you don't know, Jake does a huge majority of our engineering, especially when it comes to like the DSP stuff that I'm just too stupid to figure out. And so Jake's been working for a while. He's also been on the podcast before, talking about nerdy stuff that we all like and love. And today, a couple of different questions. The first one is from Martin Becker. Now, so before we start here, we're going to try to gear this more towards the guitar player rather than like we're not talking to Robert Keeley or anybody like that. Like they already know this stuff. So we're not going to like go into any algebra or, we don't need to take notes here, right? So we're just going to kind of explain it for, the dummy Brian, okay? All right, so the first question is, can you give an explanation on what gain actually is and the difference between gain in chords and single notes? And just to pause there, I'm not sure what he means by that. He says, is there a difference in gain when you play different chords? And what's the difference between what you describe as mathematical gain and what other guitar players are calling gain? And then he says, what are the other different methods that they can be achieved, whether it's tubes or diodes or JFETs or op amps or kitten scratching metal sheets, as he says. So that's a bunch to go through.
That's a loaded question right there.
That is. So Jake, if you're talking to me, it's 4 a.m. I just got done on my gig. I probably had a few beers, and I'm probably not wanting to do any calculations on the calculator. How would you explain all this to me?
Sure. Well, let's start with the mathematical gain and the concept of gain. Simply put, gain is just boosting the level of a signal, generally mathematically with no tonal colorations or clipping. But I think what makes gain more interesting, I think in the guitar world, is that it's generally associated with some sort of clipping, whether it's tubes or diodes or what have you. And so I think what happens there is if you take a single note or a chord and you're boosting the level so much that whatever electrical system you're playing into, whether it's tubes, diodes, or you're clipping op amps, the signal that you get out of that is not a perfect representation of the signal that comes in. It changes a little bit. You know what I mean?
Right. So I would explain it like this. Like, let's say you have like 2 pieces of bread, right? And you're squirting a bunch of mayonnaise or ketchup or mustard or whatever you like to put on your sandwich. You're like trying to fill it up as much as you can. And then stuff starts oozing out the sides because it's too full. That's clipping.
Exactly. That is in essence what clipping is. So you have different methods of clipping. I think one of the most popular in pedals is generally diodes. And so when you put diodes in with, like, let's say an op amp configuration, what happens is that you start to clip the signal that goes through. And that clipping gives you harmonics off of your original signal. And so that's where you get a lot of those higher frequencies and a little bit of that crunch. And so as you boost the volume of the signal going into that clipping stage of those diodes, you'll get more clipping. And so that's where the gain comes into, is when you're boosting the volume into a clipping stage. And that's sort of how you get that association of gain and overdrive or distortion.
Right. And that's if you're taking a stage that's multiplying volume, let's say. And then you're taking these things called diodes and you're clipping the signal so it gives the sound of distortion.
Yeah.
Right? Now, if we're talking like tubes or JFETs, it's a little different, of course, because there's not really a diode clipping. What you're actually kind of overdriving what that gain stage is capable of, and then what every gain stage after that is capable of, right? I mean, would that be a good way to explain it?
Yeah. So if you take a look at an op amp, for example, not to get too technical, but you're usually powering an op amp with, let's say, your 9-volt supply. And so if you boost your signal to a level that is greater than 9 volts, or actually a little bit less than 9 volts, then the op amp can't actually reproduce that signal. And so it'll start to clip off the top edges, giving you a pretty harsh harmonic content on top of that. And so you can take that general concept of basically trying to amplify a signal larger than your power supply voltage, and that gets you different transistor forms of clipping like JFETs, or in a very rough sense, an analogy to tubes.
Right. I don't think a lot of people understand, like, for example, a clean booster. You're getting more gain. Like that control that's boosting, that's actually increasing gain, which may or may not be clipping based on, like what you said, how it's set up.
Absolutely.
So, I think a lot of people get really confused on that idea that the gain is just your AC signal, how much it's able to boost up, right?
Right.
Like mathematically, how much that particular stage, whether it's a FET or a tube or whatever, how much it's actually able to take that signal coming into it and increase kind of like the volume of it, I guess you could call it, right?
Absolutely. Yeah, it is the volume. And I think what we generally have with the guitar and the pedal sort of terminology is that that's always associated with some sort of a clipping element. So, if you take your clean boost that you have and put it right before any sort of clipping element, then turning that volume control on the clean boost will create more clipping, because there's that clipping element, whether it's diodes or tubes or what have you.
Right, exactly. I have no idea how kittens scratching metal sheets creates gain, but it sounds cool.
Oh boy, I've got a cat, and she talks to the devil when she's in the middle of the night. She'll just go, meow, 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 meow. Scary as heck, but does not sound like kittens scratching metal sheets.
You have a possessed cat. So your cat's a spawn of Satan. My cat is just a Uni-vibe lover, so apparently it likes Hendrix. I don't know.
Oh, really? So one and the same.
Exactly. It's
two peas in a pod, I'd say.
Right. Okay, so hopefully that kind of explains what gain actually is, even though as guitar players we see the gain knob, which is creating more distortion, so we think that everything is distortion if it says gain, right? Okay, so the next question, and this is another common thing. So you have the guy that's been building, some analog pedals. Maybe he's got some build your own clone kits he's been doing. Maybe or Mad Bean stuff. I mean, he's got the analog side down, but he's wanting to get into the DSP world. Where would you tell that guy to start? I mean, I'm thinking spin chip or something like that, right? Or are you thinking more microcontroller?
If you were to ask me, that would probably be the easiest way to get a solution that you could implement pretty easily would be using the spin processor, because it's a single chip solution that takes care of a lot of the behind the scenes work that you might need to do in a larger, more sophisticated DSP, where all you really need to worry about is getting the signal in and out of the chip and then writing some simple instructions for it. So actually that's a very good place to start.
So, but you're still coding a little bit, right? Like you're still using a program to write, numbers and letters and semicolons, right?
Absolutely. There's really no way of getting around the code when you're getting involved in DSP.
So I don't know if have you seen the I think I sent you a link at one time, but it's a program where apparently you could drag and drop spin based stuff.
Oh, really?
Yeah, I don't know.
That's novel.
I don't know if it works or not, or how well it works, but I think somebody was trying to develop that at one time. I don't know.
That sounds familiar. I believe I did get that link. I didn't send that one straight to the trash.
So
sorry, go ahead.
No, I was just going to say that if you can make something like that worked fantastically, I'd totally give you 10% of it.
I'll see if I can get my computer programming skills up to snuff first. To me personally, I think a lot of the fun in DSP in writing different algorithms is actually really getting into the code in a very messy sense, and putting stuff around and calculating things, which sounds very nerdy. But I think having a GUI or a graphical user interface kind of takes a little bit of the fun away.
No, yeah, I could totally see that. So, yeah, so what you're basically saying is if you don't like doing that sort of thing, then you don't want to get a DSP.
That's true. If you, I would say that if you don't like code, then DSP is not going to be fun for you, I would say. But on the other hand, if you really just need a delay solution or a reverb or a chorus or what have you, a solution that you can really only get via DSP, then if you've got to do it, then a GUI is definitely better than nothing.
Right. And so the spin chip it's called the FV1 in case anyone wants to do some Googling. And there's different forums like you can say, hey, I'm having this problem. What should I do? And other people will answer your questions. And it's a good community of people that are kind of into this chip. But I also know that there's been several different builders who have like taken this chip and you can write, was it 9 programs you can write on the same chip? With
8.
8 programs. And so, you may have chorus on program 1, delay on program 2. And they'll just make like 3 or 4 different pedals with the same exact circuit, but it's just on a different program.
Sure.
Because,
I mean, that's an efficient way to get a physical product out there.
Right. So, that's, I'm not going to name any names. I haven't seen one do it lately, but I do know some people have done that in the past. And, you could also, actually out of the package, it comes pre-programmed with some stuff, right?
It does, yeah. I haven't given too much work into the pre-programmed stuff because for me that's no fun.
And they're not fantastic, but they definitely work. I think
they're certainly not bad at all.
I think there's a delay and a reverb and some chorus. I forget what all, but there's some stuff on there that if you just, want to throw the chip on there, then you can screw around with it, I guess. But
certainly, and to my point earlier, if you need a chorus or you need a delay with some reverb or you need something but you don't want to go into designing one, then it is a really great option to just throw onto a circuit board, like if you're making a karaoke system or some sort of an audio system that just needs a real simple effect.
Right.
You don't have to go into a whole lot with the presets already on there.
Right. So I know someone out there is going to ask me this. Is this what Strymon's using? Is this what TC Electronic is using?
Oh, absolutely. They've got 10 of these packed into their pedal, all routed with JFETs. That's what's going on in there.
Tubes, little miniature tubes.
Itty bitty tubes. No, I haven't cracked open any of their pedals, but I strongly doubt that they're using the FE1, at least with anything I know about their development abilities. So I believe they'd be using more advanced DSP tools.
Okay, so what would be the advantage of using something else, something a little more advanced, like what Strymon may be using?
Sure. Well, I know in my own experience when I started developing on the FE1, it did have some limitations. Right off the bat, they only have a limited amount of onboard memory, and memory is what you're going to be using to implement your delays and your reverbs because you have to store audio data to use it later. So, not to get too number or technical, but if you're running the FE1 as it's intended, you'll get about a second of delay time and no more than that. And so that was a little frustrating for me, even though the FE1 has stereo or left and right inputs and outputs. You couldn't do a lot of memory intensive effects that well with the limited amount of memory that you had. So you had to kind of keep it tight, small delays, right. Simple reverbs.
Yes.
Sorry.
So, no, I'm just agreeing with you. I mean, so no one is taking a spin chip and making a 2-minute looper with it.
Absolutely not. No. It is good for a lot of simple things. Like if you need a smaller delay or a simple reverb or, something with a little bit of filtering or a little bit of modulation, it can do that really well. But you can't get really expansive with it as is.
Right. Okay. Perfect. Okay, and then this is another big one. I know this. I'm hitting you hard on the DSP engineer stuff today, but you're the best.
Trying to learn all my secrets, aren't you?
You're the best person to answer this stuff. Advice. So people want to hear, like, your perspective, like coming from the engineer's perspective, on what people should do if they want to build pedals for a living. Like, I get a lot of, especially younger kids around graduation time. They're like, "I want to build pedals for a living. What should I study in college?" And I'm like, I don't think there's like a pedal building class. There's not a pedal building degree really you want to go for that I know of.
Yeah, unfortunately there isn't.
But I mean, like you of course went through college, you're degreed and everything, and during that course, I think you were still in college. You started working for me, right?
That's correct.
So, I know you and I have talked about this, but I don't think anyone else, is aware of this. So, what are the benefits, in your opinion, to having a college degree and doing what you do? And would you do the same? Would you recommend someone else do the same thing?
Would I recommend somebody else do the same thing? I would certainly say yes. I think without the degree, you can certainly build pedals and design pedals, but you are in a sense limited to designs that other people have already made, to a certain degree, because I don't think you'll necessarily right away at least have the skills or the know-how to create something entirely new. So you may be relying on previous designs to modify previous designs and then kind of design from there.
Right. Okay. So, so from that, I totally get where you're going there, but let's say you're talking to a DIYer who's been he's been building kits, right?
Okay.
He's 17 years old. He's getting ready to go to college. How would he know if he wants to go into engineering or whether he wants to stick to the breadboard and figure it out as he goes?
Sure. Okay. Well, I think one of the things I found in engineering is that while there isn't a class on building audio circuits or a class on building delays and reverbs, there's a lot of material on how circuits work, how to use microcontrollers, to use microprocessors. You even design your own DSPs at some point I think in your later years, which I think really serves you well when you're trying to do more advanced work. Like, if you are trying to dive into DSP, without that background, I know I wouldn't have been able to pick that up very quickly when I'm getting a different DSP from a manufacturer and trying to sort of hit the ground running with it. So I would say that's definitely one advantage.
You mentioned microcontrollers. What does basically what does a microcontroller allow somebody to do?
Oh, certainly. So a microcontroller is like a little simple computer that you write code for it. You give it commands, and so it'll process.
It's a tiny little iMac, just a
Yes.
tiny little bitty iMac.
Remember those Mac Minis?
It's one of those, just severely shrunken.
So right now, like let's take our designs right now. We're using a microcontroller to handle all of the switching elements in there.
Okay, so that means it's not true bypass then.
Yes, it is.
But
Am I allowed to talk about this?
Yeah. Well, I mean, you don't want to give away our secrets, of course.
Well,
like we don't want to teach our competition how to make kick-ass pedals like we do. So
that's true. Okay, I'll keep it simple then. No, but what you can do with a microcontroller is you can take inputs like from a switch, and you can send outputs based on those inputs, which is very generalized. But what it also allows you to do is, and what I've been doing a lot lately with it, has been able to develop LFOs, or low frequency oscillators. So I can use a microcontroller to send out sine waves or triangle waves to other components in the analog circuit to control different parameters, which would have otherwise required more cumbersome analog oscillators.
Right. So
with less control.
You're controlling UFOs with it. I got it. Yep. Makes total. UFO is the same as an LFO, right? Okay, so basically, so that microcontroller is in Martinsville, Indiana speak, which is a bit hillbilly. It'd be like, "Hey, when I turn that switch on, you better turn that damn relay on and off," right?
Exactly.
But It's just done in a more, a little bit better way than hillbillionized. I made that word up, but I'm going to use it.
Mhm.
So,
And actually, there's it's probably, I'm sure if anybody's familiar with a little bit of microcontrollers, they've probably heard about the Arduino. And actually, that is probably another tool I would recommend for those who are new to microcontrollers. That's a very, very good tool to sort of get your feet wet with, because there's a lot of forum content and online material to help you get through different projects. And it really gives you a wealth of information about how you would implement microcontroller solutions in a variety of projects.
and that one's a lot different than the spin, where the spin is like, here's how you make some guitar effects. The Arduino is more like, here's how you can do a bunch of different stuff, right?
Exactly. So you have to sort of use your imagination, figure out, how would I apply this to what I'm trying to do with my solution? It's not something that'll say, oh, this is how you use this in guitar pedals. That doesn't necessarily parallel immediately.
Maybe that's your next Udemy course, or your lynda.com course, is how to program guitar pedals with the Arduino. See, there you go. Already made you another business right there.
Fantastic.
So far we've got the FV1 interface that we're partners on, and and now we have the how to make an Arduino, which is something like an R2D2, into a guitar pedal, right?
Right. Well, at this rate, with all this work you're giving me, I'm going to have to expand. I'm going to need some more of these. I'm going to need more of these engineers wanting to get into a pedal building, to start giving me some calls and say, hey, let me help.
That's a good question. So the guys that you went to school with, I know there's a couple of them, but how many people in engineering class do you think are even remotely interested in learning anything about guitar pedals?
I think there's a fair few of them who would be interested. I don't think I could quantify that well.
I mean, like, do you like, as you were, I know you were doing different projects with guitar effects when you're going through school. Were there a lot of people that were like into that, like as a guitar player, like, oh, that's cool, I would love to use that effect or something?
Yeah, there were a small few. I think when I was, at least the people that I was associating, not associating with, that sounds awful. The people that I was working with most of the time generally found that audio circuitry and audio processing was sort of a black magic compared to maybe what they were working on at the time. So I wouldn't say that all electrical engineers kind of have that assumption, but it was more frequent than what I had anticipated.
Is that just because, I mean, when you say it was black magic, is that because there's a lot of weirdness? Like, for example, in guitar pedals, clipping is good in a distortion circuit, but in some pro audio, clipping is really bad. Mm-hmm. Is that what you mean? Like, there's a bunch of things like that as an engineer, you wouldn't necessarily be designing a circuit to clip poorly.
Certainly, yeah. A lot of the solutions, and I'll say solutions, quote unquote, that we have for different guitar signals and effects, like distortion or clipping or delays or reverbs, that you would never imagine using those types of electronic solutions for any other process. Like, at no point do you want to clip your signal, generally speaking, or at no point do you want to delay your signal and feed it back into itself for any useful purpose. So a lot of the tools that you use, or not a lot of the tools, but a lot of the processes that you're using in designing guitar effects are unique to audio. But a lot of the tools actually remain the same, in that you're using, let's say a DSP, for example, you're using a processor to process sampled audio, and then you're interfacing it with memory. So a lot of those tools are actually much the same. It's just what you're using those tools for is largely different than you would in a more of a classical computer or electrical engineering job.
Right. Makes total sense. Okay, so a few more things, and then I'll let you get back to the real work. Through school, how much did they talk about analog stuff, like analog audio?
Let's see. Very, very few. I think when I started out, I took maybe two or three classes and 2 or 3 labs that dealt with anything that was possibly related to audio. The first one was just the basic circuits. So we talked a lot about the op-amp theory and how they work. And then I had, following that, a lab on semiconductors. So anything from like your transistors to your MOSFETs, we talked about how they work, and it's fantastic. It's super interesting how they actually work physically. But then we also had different labs where we would design specific AC amplifiers with variable gain that had nothing to do with clipping. But beyond that, really, it wasn't that much as far as analog audio processing.
So no fuzz face courses or anything then?
No, certainly not.
Did you ever, just for fun, ask anything stupid like, so if I want to saturate this and make this a really good fuzz, how would I do that?
No, I didn't. Although I did design for one of my laboratories a distortion circuit. I designed one, and then I had to perform a bunch of frequency analysis plots on it to analyze its response. And it was unique among everyone else's project in that there was clipping and saturation and seemingly useless tone controls.
So your professor was like, I don't know whether to flunk you on this or ask you how you did it.
Well, luckily it was a graduate TA, so he understood. He's like, I get it. This is useless, but I'll pass you.
You'll never use this, but fine.
Yep, it sounded terrible. I'll give him that much.
Little did he know Jake would be doing effects full time.
Oh yes.
Sitting on the beach in his Speedo, coding like a madman. Right? That's what I'm picturing you doing day to day.
Only one of those is false.
Well, you need to code more then.
No, the beach or the Speedo part.
Oh, okay. One other thing.
I'll let the listeners decide.
Exactly. What about tubes? Did you guys discuss tubes at all in engineering school?
No, we did not. At least
really?
Not in depth. It was sort of in passing, like, oh, we used to use tubes, but then we designed semiconductors, and they work way better. Let me say, in parentheses, they work way better for all practical applications that aren't audio related.
So it's kind of like if you're learning mechanical engineering and they're talking about vehicles, and they're like, we used to have horses, but we don't anymore because we got cars now.
Yes, very similar to that. Well, can you imagine trying to run your tablet or your laptop off of tube circuitry? It would be insane. You know, the development of the transistor and the miniaturization of it allows you to have very high power and very complex devices in a very small space.
That's very cool. But the question is, how would the iPad sound if it was run off tubes?
I think they've got an app for that.
Oh my goodness. All right. So, so for the nerd episode of the Chasing Tone podcast, is there anything else that you would like to talk to this guy that, and not just Martin Becker that has questions, but this particular type of demographic that has been asking me the DSP DIY questions? Is there any recommendations you would give them? Maybe books to read, maybe classes, maybe, life lessons that you learned?
Well, there's actually a book that you referred me to. It's called The Art of Electronics, and that has quite a bit of content as far as more theoretical, well, not just theoretical, but applicable electronics information. The one caveat there is that it's not going to say, this is how you build, a circuit here or there. This is how you build a distortion circuit or a delay circuit. But it gives you a lot of the basic elements that say if you didn't want to go to college, or maybe you're in high school and you're still debating whether or not you want to, make that choice. It's a very good tool. It's a very good learning material for learning a lot of these electrical concepts that you can actually use if you have the creativity to then go implement them in an audio circuit.
Right. I would call that like the Bible for anyone interested in bigger electronic studies than like building your own pedal from a kit. You know what I mean?
Absolutely, yeah. That is called The Art of Electronics, 3rd edition. It's fantastic.
And it's expensive too, but it's worth it. Yeah, it's
yeah, it's worth every penny.
It's like the thickness of Moby Dick or something like that. It's like 10,000 pages. It's crazy. Mm-hmm. So, all right. Well, thanks for hopping on here and being my guest this week.
Yeah, no problem. Thanks for having me.
If anyone has any questions for you, are you open to answering them?
Yeah, if anybody had any questions for me, just shoot me an email. That's probably the best way to get a hold of me. And my email is jakesteffes@gmail.com. I think if you want that email, you can ask Brian for it.
It's real. You could do that too, yeah. So, all right, man. Thanks a lot. Appreciate it.
Cool.
And to everyone else out there, if you, like Jake said, if you have any questions, you can either shoot him an email or shoot me an email. So thanks for listening to the Chasing Toad podcast. I really appreciate it. If you have any questions for me, you can always email podcast@wamplerpedals.com. So once again, thanks for listening. Tell all your friends, and make sure you check us out next week.